Time for some more chemistry. This will be a video on determining the percent water in a hydrate through experimentation. You're probably sick of hydrates. We've done molar mass of hydrates, percent water in hydrates, a calculation on how to determine the mass of water in a certain mass of hydrate. So now we're going to do it experimentally. So again, this is a hydrate. We're going to use this sodium sulfate pentahydrate. Again, a hydrate is an ionic compound with waters embedded in the crystal structure of the compound. So here I've got this brown color. That is going to be this sodium sulfate. And the 5 waters obviously are my blue thing. So just looking at this hydrate, this is again a good, I feel a good representation of it, but you personally can't take out the waters just with your fingers or your hands. You have to actually heat up the hydrate. So basically heat it up over a burner, get the fire going, and eventually what should happen is that the water molecules should slowly vaporize. And what you'll end up getting is just this compound. Now eventually, again, all those waters will go away. You'll be left with just the sodium sulfate, which is something called an anhydrous solid. That's an O. So in lab, we're going to basically try to figure out the percent water through experimentation using this method. And I've got some numbers in a data table in a little bit. All right, so let's say we're still using that sodium sulfate pentahydrate compound. We again need to figure out the percent water experimentally. You can obviously figure it out using math, just calculations like we did in other videos or like you've done in class. But we're going to do it experimentally with just data that I used in a lab I did before. So you can't just heat up the pure solid. You have to actually put it in something. So we're going to put it in an evaporating dish. Let's say that's the mass of the dish. Then I plop the hydrate in. All right, and afterwards we get 27.12. Using some quick subtraction, we figure out the hydrate mass is 1.35 grams. Just from subtracting the dish from the dish and the hydrate, we get 1.35 grams. Cool. All right, so at this point we're gonna heat it up, all right, over the burner after, I don't know, 5 or so minutes after constant heating. We're gonna end up massing this thing after it cools, and we get an evaporating dish and anhydrous solid. Again, anhydrous means no water, so hopefully all the water is gone. Let's say we get a mass of 26.59 grams. It has to be lower than the initial mass. All right, it doesn't make sense if you lost water and somehow gained mass. So now we lost some water. In order to find out the mass of the anhydrous solid, all right, again, we need to do some subtraction. Because here we have the dish and the solid, the anhydrous. All right, we don't care about the actual hydrate anymore. So if we subtract the dish, all right, so the dish up here from what we have down here, we end up getting an anhydrous solid mass of 0.82 grams. So obviously it's less than the hydrate, which is good because we lost some water. It's like if you lose weight with with water mass. Obviously you lose water mass, so you're going to be lighter. Then to find the water that evaporated, obviously you can't just collect all the water that evaporated and mass it. So you have to use just, the power of subtraction. In this case, the hydrate was 1.35 grams. Again, the hydrate has the water included, the anhydrous doesn't. So if we just subtract those two, we get the mass of water that evaporated, which will end up being 0.53 grams. Awesome. Finally, to find the percent water experimentally. Percent, again, is a part over the whole. So the part in our experiment will be the part we really care about. We want to know, percent water. So we're going to use 0.53 grams. So I'm going to move on up here. In our calculation, we'll do 0.53 grams. That's the part, divided by the whole. Now for the whole, we're going to use the hydrate because that has the water and the anhydrous solid. It's got both of them. Just like if you found the percent water normally, just with the formula of the hydrate, you would use the molar mass of the water on top and the overall whole molar mass on the bottom. So in this case, we're going to use the mass of water that we calculated up top, and then the mass of the hydrate on the bottom. If we multiply by 100, we'll get our percent water. All right, so using significant figures, just two of them, due to the two up there, we get 39% water experimentally in the hydrate. The actual percent water, in other words, the theoretical percent water actually is 38.81%. If you were, again, to use that sodium sulfate pentahydrate and actually just calculate the percent water using the formula, you get 38.81%. Via lab, we get roughly 39%. Again, it's tough to get this precise using not as precise balances. In this case, balances that only go to 2 decimal places or the hundredths place. But in this case, we get 39%. That is how you are to determine the percent water experimentally. That's it. Thanks for watching.